OK. That's one class of attacks, is trying to inject into an existing connection. Now, a somewhat different class of attacks you can do with TCP is to try and create your own malicious connection instead of injecting into someone else's connection. So this is a different class of attacks called TCP spoofing. And now the idea is, instead of injecting into an existing connection that's already opened and has two people talking, you are instead going to try and create a new connection that previously didn't exist. And what's going to make it malicious is the fact that you're going to pretend to be someone else in this connection. So for example, if you're Mallory, you might start a new TCP connection, but try and pretend to be Alice in this connection. So you want to pretend to be Alice, and if you succeed, maybe you can trick the server into thinking that you're Alice, and you can access Alice's bank account, or send money to Mallory, or do other malicious things. So our goal is to create a brand new TCP connection that didn't previously exist, but do so while pretending to be someone else. So here it is in pictures. Here is the client. Here is the server. So this is the legitimate client, like Alice. And here's the legitimate server, like the bank. So the first thing we're going to do, because we're trying to create a new connection, is send the SYN packet. This is the first part of the handshake. But it's not going to be Alice sending the SYN packet. We're trying to make a new connection and pretend to be Alice. So instead, Mallory is the one that creates this malicious SYN packet. And she sets the sequence number to any random number she likes. This can be any random starting number. And she sends it to the server. So once again, think about who's really sending this packet. That's Mallory. But who is she pretending to be? What does the from field of the header say? It says from Alice. So it's a lie. So this is a spoofed packet that we send to the server. Now here comes the interesting part. If the server receives a SYN, we know they're going to reply with a SYN-ACK packet. That's the second step of a TCP handshake. But where do you think the SYN-ACK packet is going? Is it going here to the client? Is it going back to Mallory? Is it going somewhere else entirely? Where's the server going to send that SYN-ACK packet? Well, if I think about the server, what does the server see? The server sees a packet that says from Alice to server, because this is a spoofed packet. So the from field is a lie. So it says from Alice to server. So if the server sees a packet that says from Alice to server, where's the reply going? Well, not to Mallory. This packet doesn't say Mallory anywhere. It's going to the client. So this is a tricky thing to wrap your head around the first time. But because this is a spoofed packet, and it says from Alice, the reply is going back to Alice and not the attacker. So this is what a TCP spoofing attack looks like. You start the handshake maliciously, and the server sends the second part of the handshake, not to the attacker, but to the actual legitimate client. Now, if you're the attacker, your goal is to finish the handshake by sending an ACK packet, and then start injecting evil data pretending to be Alice. So this is what a successful TCP spoofing attack looks like. And now we can think about how hard it is for each type of attacker to do this. Well, I guess before we do that, if you consider the client, what is the client thinking at this point? Well, the client is going about their day, and they suddenly see a SYN-ACK. Well, that's kind of weird. The client never sent a SYN packet, and somehow they got a SYN-ACK. How do you get the second step of a TCP handshake when you never sent the first step? So this client is going to be totally confused. And when you're confused and you don't know what to do, you'll send a reset packet to say, I have no idea what's going on. I wasn't trying to talk to you, so I don't want to keep talking. I'm leaving, and here's a reset packet. So usually what will happen eventually is that the client will send a reset packet, and the server will cut off this connection. So this connection might not last very long, but eventually the client will send that reset packet. So this is a picture of TCP spoofing succeeding. Now let's think about the three types of attackers and who can carry out this attack. So if you're a man in the middle, once again, it's easy. There's no cryptography. You can create the SYN packet. Anybody can do that. when the server sends the SYN-ACK, you can peek at these two values, y and x. Well, you know x because you picked your own x. But you can peek at y and then copy that value here and write y plus 1 to make sure the server accepts your ACK. And then you can start sending your evil data. As a man in the middle, you could even drop the reset packet so that this connection stays open forever. And now the man in the middle is successfully created a connection pretending to be Alice. So that's what a man in the middle could do. They don't have any challenges. What if you're an on-path attacker? Well, once again, anybody can create the SYN packet. You're just spoofing. And the on-path attacker can read the SYN-ACK and copy the value y into their second spoofed packet and write y plus 1 here, send it over. They have a race condition where this needs to arrive before the reset packet, just like before. And those are the challenges for the on-path attacker. So if you're on-path, you can copy this value easily, and you just have to win this race condition. Now finally, the off-path attacker. Once again, the off-path attacker has a guessing challenge that the other two attackers don't. The off-path attacker can still create this first packet. This x is chosen by the client. So the off-path attacker can choose any value of x that they want. That's no problem. But then the off-path attacker can't read the SYN-ACK packet. So when the off-path attacker goes to create this fake ACK packet, well, they know x, they chose it, but they don't know y. Y was sent here, the attacker can't read it, so the off-path attacker doesn't know how to fill in this field. They have to guess. So they still have to win the race condition, but they have an additional guessing challenge that the other two attackers don't. So that's TCP spoofing. If you're a man in the middle, easy. If you're on path, you have to win that race condition. And if you're off path, you also have to guess this value. And here was everything I said in text. Sometimes people call the off-path version blind spoofing, where blind means you can't see the packets that are being sent.